We are going to work a stoichiometry level 2 question where we are converting molecules of one substance to moles of another substance. We already have our balanced chemical equation. The question reads, from the combustion of propane, how many moles of CO2 will be produced with 5.80 times 10 to the 23rd molecules of H2O? I want to start by writing my given value of 5.8 times 10 to the 23rd molecules of H2O over my H2O in my balanced chemical equation. 5.80 times 10 to the 23rd molecules. Then I want to write my given, rather my unknown, which is how many moles of CO2, as X moles over my CO2. At this point, before setting up my proportion, I want to make sure my units on the top and bottom of the proportion will match. So from my balanced equation, this 3 represents the 3 moles needed for this balanced chemical equation to happen. So under my 3 CO2, I'm going to write 3 moles. Now, for my 4 H2O, I have molecules. So I need to determine how many molecules are in 4 moles of H2O. Well, we know that 1 mole equals 6.02 times 10 to the 23rd molecules. And that represents Avogadro's number. So if 1 mole equals 6.02 times 10 to the 23rd molecules, we can work out that 4 moles is going to be 4 times 6.02 times 10 to the 23rd. When we calculate that, we get 2.408 times 10 to the 24 molecules. And that's how many molecules are in 4 moles of H2O. Now I have everything I need to set up my proportion. So X moles over 3 moles equals 5.80 times 10 to the 23rd molecules over 2.408 times 10 to the 24 molecules. At this point, I cross multiply and can solve for X. Multiplying this way, I get 2.408 times 10 to the 24 X equal to, multiplying this way, 3 times 5.8 times 10 to the 23rd, I get 1.74 times 10 to the 24. To solve for X, I divide both sides by 2.408 times 10 to the 24. That comes out to be X equals 0.72259. When I check how many sig figs I need, I go back to the original value given in the problem. This 5.80 has 3 significant figures. So I want my answer to have 3 significant figures. The leading 0 in front of the decimal does not count, so I have 1, 2, 3. I look at this 5, and it rounds that 2 up to a 3. So my answer becomes 0.723. To determine my units needed, I go back to this original question. How many moles of CO2? So my answer, 0.723, represents moles of CO2. And that is my final answer for the number of moles of CO2 produced when 5.80 times 10 to the 23rd molecules of H2O react.